In lesson 8.3a, we're going to do the foundation of trigonometry. We won't be doing any of the real-life examples yet. That's in 8.3c. But trigonometry is a very useful field of mathematics. So I have this YouTube video up where it says some of the real-life applications. I'm just going to speed through it a little bit so you can see. So first of all, trigonometry is used to measure the heights of things like mountains and skyscrapers, monuments, tall buildings, where it wouldn't be logical or even feasible to use a measuring tool, like a tape measure. Who could get the height of a mountain with a tape measure? We also use trigonometry in the real world. Get past this example here, we'll figure out how to use it later. For things that measure angles of inclination, okay, and depression. It's used in criminology for blood splatter, finding the angle of impact. I don't know how yet, I just want to show you where it's going here. It's used in construction a lot, in particular for things like ramps and escalators and those things that make those natural right triangles. It's used with astronomy and astrology for suns and stars distances, again, where things are so large, it'd be really hard to measure. Also used in physics for velocities and in gaming. Also used in navigation, so at sea or out in the ocean, again, where things are too difficult to measure by hand. And then this is sine wave frequencies, used in music for music frequencies, and then a whole lot of other stuff that's got some weird higher level math attached to it as well. So what we're going to do first today is we're going to hop in our notes and we're just going to do some very what would it be called? Foundational, where I'm just going to teach you the language of trigonometry and then we'll get started using it to find missing pieces, because the reason it's called trigonometry is tri for triangle, metry for measure. So it's finding measures in a triangle. You will need a calculator at the end of this lesson, so when we do, we'll just pop up. For the beginning of it here, we do not need a calculator. So first of all, I want to talk about what trigonometry does. It uses the sides of right triangles. You can see I've got a red hypotenuse, a blue, what I call opposite side. I think it'll serve us better in here to call this an X. Calculus, we call it that Greek letter theta, but we're going to call it X. And there's 3 ratios of the sides. There's actually 6 trig ratios, but we're only going to work with 3 of them here in geometry. And remember, a ratio is a fraction. So you're going to be setting up fractions of these sides. So I'm going to, up here, put 3 sides that make a right triangle. If this was 5, actually let's put 5 on the shorter side. If this was 5, and this is 12, and this is 13. There are 3 ratios that get special names. They're actually called sine, cosine, and tangent. There's 3 others that are these guys flipped over, but that's for another level of math. And what this sine function is it's just a ratio of the length of the side opposite the angle, so that would be 5, over the hypotenuse of the angle, which is always across from the right angle, which is 13. So we'd say that the sine ratio is 5 over 13. And it gets abbreviated SIN. You can see that on your calculator, but don't call this sin, don't call this cos, and you can call that tan. It's actually sine, cosine, and tangent, but we abbreviate them all to 3 letters. And you might say, well, I don't get why they call it sine. Neither do I, just like I don't get why they call what's on my foot a shoe. It's just a title for a ratio, where shoe is a title for this thing on my foot. All right? So the cosine ratio, what we do is we grab the side adjacent to the angle, and you might say there's 2 of them. And adjacent means touching, but the one across from the right angle always gets to be the hypotenuse, always. And you're going to always identify that first, hypotenuse, always, okay? So we grab the adjacent side to the angle that we're looking at, which is the 12, and we put it over the length of the hypotenuse. This only works for right triangles, and I purposely made a triple or 3 pairs of numbers where this is true, where 25 plus 144 does equal 13 squared. Okay, so this is only for right triangles. The tangent ratio is the side opposite the angle, the 5, over the side adjacent to the angle that's not the hypotenuse. So you're really, when you're doing these ratios, you're just setting up fractions that represent 2 particular sides on the triangle. So right now it should be a little bit confusing, but that's why we're going to go practice it. All right, so it says, do the sides make a right triangle? So that's another section. They do if c squared equals a squared plus b squared. So let's go check that out. Does 10 squared equal, I don't know yet, 8 squared plus 6 squared? So if you go to your calculator or in your head, do 10 squared, you'll get 100. On the right-hand side, if you do 8 squared, 64, plus 6 squared, 36, you also get 100. So yes, this can use right triangle trigonometry. It says, what acronym can we use to set up the ratios? We're going to use this guy right here. It's called SOHCAHTOA. If you ask any math student beyond geometry semester 2, what you use when you're doing trigonometry, they'd say, oh, that's SOHCAHTOA. It's just an acronym, right? Which is letters that help you remember what to do. I like to write it, though, instead of like so and then ka and then toa, I like to write it like this so I know that the sine ratio, I need to do opposite the angle over the hypotenuse. Cosine, I need to do adjacent to the angle over the hypotenuse. And tangent, I need to do opposite the angle over adjacent. So the first thing we need to do is identify what angle they're asking me to look at. I always tell kids, put an arc in that angle. That means you're going to ignore angle B when you're doing the sine of angle A. The sine ratio is opposite, straight across, but I like to label them, again, for angle A, this is always the hypotenuse. For angle A, this is the opposite side. And for angle A, that's the adjacent. I like to do hypotenuse, opposite, and the last one is adjacent. And again, that hypotenuse always across from the right angle. So let's go do all these angle A ones first, since I already have it diagrammed up here. To do the sine, I need to do the side opposite it, which is 6, over the hypotenuse, which is 10. And then it says to simplify that. So we'd make that 3/5. I just don't have enough room in the box. Let's go do the tangent ratio, TOA. I need to again do the side opposite the angle that it's stating, angle A. This is a command. It means kind of like this is a command. Take the square root of 9. This is just new, but when you see that tan, it means go ahead and grab the side opposite the angle they're telling you, which in this case is 6, over the side adjacent, which is, in this case, an 8. And again, you might say these two are both adjacent, LaRude. The one across from the right angle always gets to be the hypotenuse. So this would be 6 over 8, which is equal to 3/4. Again, you don't know yet the application of this. We're just giving you the working tools for it. So last one that deals with my eyes looking at angle A is the cosine. And it's so ka, so I need A over H. So I need 8 over 10, and again, I'd simplify it. Now, when they change the angle that I'm supposed to be looking at, in this case, I'm supposed to be looking at angle B. So I go right here and I say, this is where I'm looking. The hypotenuse is still the 10. That will not change. But now, when I go opposite, it's the 8. And when I go adjacent, it's the 6. And again, do it in that order. Head across from the right angle, head across from the angle that you're supposed to be looking at, in this case, angle B, and now follow the directions. I'm supposed to command you to take the cosine, which means I'm telling you to grab the adjacent side to angle B. Okay, so now I'm adjacent to angle B. That's this guy, which would be 6, over the hypotenuse, which is still 10. And I've reduced that to 3/5. Tangent of angle B means TOA, grab the opposite to angle B, that's the 8, over the adjacent to angle B, and that's the 6. It's just ratios of sides. So that would be opposite over adjacent, and we'd call that 4/3. And you'll notice when I switched angles, these just flipped over because what was opposite of one is now adjacent when I switched those angles. I challenge you to set up the sine of angle B, so your eyes are still looking at angle B, but the sine command means grab the opposite over the hypotenuse. The hypotenuse is 10 in all of these problems. The side opposite of B is an 8, whereas the side opposite of A was the 6. So they kind of change. And again, you would reduce those. So now I have on here practice the maze for 10 minutes. And that's linked on today's Schoology slide. So I'm going to extend this page. Actually, I don't think I am. I think I'm going to page forward. Got a lot going on here on my screen, so just give me a second. I'm going to move this. I think I'll go a new page, and I'm going to go right here. So the maze worksheet on the very front side says to begin in the first square and follow the correct trig ratios to complete the maze. So the first one was cosine of A, and it had a triangle that had a B at the right angle, an A at the left peak, and a C at the top. It had a 45 on the hypotenuse, and a 36 on this leg, and a 27 on this leg. So the notes, the directives at the top say put a dot in the angle, and then label each side. So this said cosine A, either put a dot or an arc. And then it says label each side. Always do the H first. Then the side across from the angle is the opposite. The lone one is A. This said to do cosine. At the top of your paper, you might want to write SOHCAHTOA. That's what you do when you have frostbite. SOHCAHTOA. All right. So I'm supposed to do the cosine. Okay. My cosine would be, and we'd still be in that top box, so you kind of have to write small if you don't like to go to a separate sheet of paper. But cosine is adjacent to B, which I've labeled as the 27, over the hypotenuse, which is 45. I need to reduce that either in my head by dividing out a 9, or on my calculator, which will divide out a 9. I get 3/5, which means I'm going to shade in over here where it says 3/5. Boom, 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 boom. And it's going to take me to the next question, which would be to the right. So this is going to follow a maze. I'll do one more with you. This one says your triangle is tilted like this. There's a right angle here. You're to do the sine operation, which means grab the opposite over the hypotenuse of angle A. Angle A was at the peak over here. Angle B was at the right angle. Angle C was up here. The sides given were 24, 30, and 18. So the sine of angle A, first of all, we have to go focus on angle A, put an arc or a dot or something. Always do hypotenuse, then opposite, and the lone one is the adjacent. Hypotenuse, head across, the leftover one is the adjacent. And you might want to go to a separate sheet. These are little tiny, and just label them 1, 2, 3, but at least shade so you can see your maze going. So the sine would be opposite of A, which is the 24, over hypotenuse, which is the 30. When I reduce those, or divide them each by 6, I'd get a 4 on the top and a 5 on the bottom, which means I'm going to continue, shade in 4/5, and I'm going to continue to the next box. And it's going to take you down to the bottom. Don't worry about not getting too far today. It's due on Thursday. I would stop and practice that for a little while because that's what we did in class. But I'm going to go back and continue with the notes. Okay? So the next thing it says is our calculators are programmed to find these ratios. It doesn't matter how big. Oh, why that's not right. It only does it here. I'm going to go a little bit full screen on this, I think. View, full screen. Should keep the calculator in front there, yeah. So, I'm going to just move it down. It says our calculators are programmed to find the trigonometric ratios. You need to set your calculator to degree mode first. When you buy it, it's not in degree mode. So you're going to hit mode. It's right there. You can see it in red. If you have a TI-34, those only do degree mode. So you're going to go down, down. When you buy these, they're defaulted to radian. So you just need to move the arrow over and hit enter. Okay? If you have the TI-34s, or the non-graphing calculators, it only does degrees, so you don't need to worry about that. Honestly, you won't move that out of there until you get to maybe pre-calc or calculus. You'll only be working with degrees until then. So hit second quit, and you're left with the screen right here. So it says we're going to use our calculator to find the ratios and round it to 4 decimal places. So you see on your calculator the commands are sine, which means what's the ratio to opposite over hypotenuse, adjacent over hypotenuse, and tangent is opposite over adjacent. You just need to enter the angle measure. So you'll see on here I did sine of 47 degrees. The sine of 47 degrees. It means no matter what 47-degree angle is constructed, when you divide the opposite side by the hypotenuse, you will always get 0.73135. But it says to 4 decimal places, so we go to the 4th decimal place, we look to the right, and there was a 5, so we bump it up. So we'd say 0.7314. So let's go practice that a little bit. Sine of 52, boom, 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 boom. When I was in school, our calculators didn't do this. We had to use a table. 7880. So you tell your calculator the command, tangent, you tell it what angle, enter it, and you hit enter, and you get a 1. Talk about why that's so nice and the other ones are so ugly. Notice this is our special triangle. That's going to be part of the reason why. And then let's just try one. A cosine 89 degrees would equal 0.0175 to the 4th decimal place. Now right here, y is the tangent of 45, 1. Remember the 45 is half of a square. And for the 45, the legs are always equal. So whatever this is the same. If this is a 7, this is a 7. Well, remember tangent, TOA, I have to grab the side opposite the 45er, x, and put it over the side adjacent. Remember, this one over here is always the hypotenuse. And whenever I do x over x, 7 over 7, 5 over 5, I will get a 1. So that's why a tangent one for 45 degrees is so nice. Now this is where it starts getting important. That was all what I'd call in English vocabulary. Now we're going to learn, if I were to compare it to English, how to write a paper. And then when we do the applications, we're going to write a world-selling epic novel. Now that you can set up the trig ratios using our SO, CA, TOA, and can use your calculator to evaluate, you can put these together to solve for a missing side. You might say, LaRue, we've already done that with the Pythagorean theorem. And I say, you need 2 sides to do a squared plus b squared equals c squared. I only have 1. You might say, yeah, but what about that special triangle stuff? This isn't 45 degrees, and it's not 30 or 60 either. So when that happens, you're forced to go to trigonometry, and here's your steps. You are going to arc the angle given. What's the angle given? 47 degrees. There'll always be a right angle. Another one will be marked. That's where your eyeballs go. You look here and you don't look away. You're going to label the hypotenuse, opposite, and adjacent. Hypotenuse is always across from the right angle. Opposite is across from the angle given. The loner, or the third one, you will always call the adjacent side. We're going to decide which trig ratio we're going to use by crossing off the letter that has nothing with it. H has a 15, O has an X, A is not needed for this problem. Okay, that's going to help us decide whether we should use sine, because we have opposite and hypotenuse, cosine, because you get it, right? We're going to choose the sine for this one. We're going to set up the ratio. We're going to say, I know that the sine of my angle has to equal the opposite over the hypotenuse. Okay, so opposite over hypotenuse, so for the sine. This is a number. Now, we're going to avoid, let's for this first one, write it down, but then we won't do it again. Sine of 47 is a number. I'm just going to go to my calculator. I'm going to do sine. Actually, I did it up here. Sine of 47 is, but I'm going to do it again. Sine 47, enter. The sine of 47 is 0.731, etc. So I'm going to write it here, 0.7314-ish is equal to x over 15. And now what it says is, on your fifth step, multiply by the denominator. We're going to multiply both sides by 15. They will cancel. So I'm going to multiply by 15, but it's already on there. So I can just go times 15. 15, enter. And I get 10.97. So x is about 10.97. Now really, we don't need to change it to a decimal because it's logged and programmed and stored in our calculator. So I could have just said, well, I'm going to multiply by 15 and gone to my calculator and just done one entry of 15 sine, sorry, I have to put my pen down, sine 47, and it'll save us that step of changing it to a decimal as we go. That one should have been a little confusing, but now we should be better as we go. I'm going to bring my calculator over to this side, get it out of the way a little bit. So what are my steps? The steps are, number one, lock your eyes in at that, lock your eyes into that given angle. So we're just going to go up here, we're going to go lock your eyes in right here. That is where you're looking. Label the hypotenuse, the side opposite, and then the third one will be the adjacent. Cross off the one that doesn't have a partner. Decide if you're going to do sine because you have opposite and hypotenuse, cosine because you have adjacent and hypotenuse, or tangent because you have opposite and adjacent. You can see for this one right here that I have on my triangle the adjacent that I'm looking for and the hypotenuse. So what I'm going to do is set up a cosine ratio. The cosine of my angle given is the side adjacent over the hypotenuse. We will multiply by the denominator. It will kill it off on the right. If I multiply this by 17, the 17 over 17 is going to cancel. And on the left, I get 17 cosine 54. This is a decimal. If your heart desires to go change it to a decimal, go ahead. But it's already programmed in your calculator. So it's already perfectly fine if you just go 17, and then you go cosine, and then you go 54, and then you go enter. Let's round that to the hundredths, and we'd say x is almost 10. It's about 9.99. All right? So let's go do our last one together. And again, let's see if you got that algorithm down. Where am I looking? This is the angle I was given. My eyes will not leave that. I'm going to label the hypotenuse first. It's always across from the right angle. I'm going to label the side opposite the one I'm staring at, and then I'm going to label the other one. The one without a partner, I'm going to cross off. The other two tell me which of these guys I'm going to use, and this would be a TOA setup, a tangent ratio. So the tangent of my 28-degree angle is the side opposite over the adjacent. Now this one's a little different, but if you look at your steps, it says multiply by the denominator. So you're still going to multiply by the denominator to kill it on the right. You're going to multiply the right by W, and it's going to cancel. You're going to multiply the left by W. And this is going to require one more step, because if the denominator was X or W or P or the variable, you need to get rid of this number. Now you could write it down if you wanted. You could go, well, what number is that? You could go to your calculator, go tangent 28, enter, and you could write down 0.5317 on it, but your calculator has it in there. So why not just divide both sides by tangent 28 and make your calculator just work with that decimal? So we're going to say 1 divided by the tangent of 28 equals. And we'd say about is about 1.88. All right, so that's it for the notes, okay? But we're back to our maze sheet, so let's go back to the maze. I'm going to get a clean sheet of paper here, so actually I'm just going to go find a clean sheet instead of, there we go. So on the maze, we're going, don't worry about page 1, okay, right now. We have a little more time to work tomorrow. We're going to go to the next page, and we are going to start where it says start, but now you're going to be on a separate sheet of paper, and that's why there's 3 sheets on there. So the third sheet is blank. On the top of it, you're going to write maze, and you're going to write 8.3C just in case it gets torn off or something, and that's where you're going to put the work for these. And I would rip it off, honestly, so that you can have them side by side. So in the top left, we have the right triangle. It says start, and there's a 15 here, and there's a 38 here. And again, this maze is linked on the slide. So if you don't have a printer, you can just work on a separate sheet of paper. I'm totally fine with that. Let's go through our process. We're going to show all our work neatly, and it's going to work us to the finish line. Our eyeballs are going to go right here. We're going to label the one across from the right angle first. The one across from the angle I just arced second. The other one gets the A in it. We'll cross off the one that does not have a partner. At the top of our paper, maybe we want to write so, ka, toa. All right, now I have the A and I have the H left, okay? So I'm going to set up a cosine ratio. So you're going to say the cosine of the angle given. It's a command. Take the cosine of 38 degrees, which means grab its adjacent side, which is 15, and put it over the hypotenuse, which is x. The next step says multiply by the denominator. In this case, it was an x. And then your steps say, if it was an x, you're going to need to divide. You don't need to show this. And that's a number, but again, you don't need to go change it to a decimal because your calculator already has it in there. So the only time you should really need to go to your calculator is right at the end, and it'll take care of doing 15 divided by the cosine of 38 for you. You're going to hit enter, and it's going to say 19.0 to the nearest tenth, which is going to send you coloring in this arrow that's on the right. So you can go ahead and shade that in. You're heading this way to the next problem. And you don't need to redraw them on your work. Arc the one they give you, 13 here, and maybe one more together, because this is really an important section. So how do these start? Here we go. We put our eyes here. We label the hypotenuse. We label the side opposite the angle in question, and we label the adjacent side. We cross off the one that does not have a partner. It triggers us to choose the ratio that involves opposite and adjacent. which is tangent. So we say the tangent of our 43-degree angle is equal to the opposite over the adjacent. We multiply by the denominator, in this case it's an x, it will kill it on the right and put it out front over here on the left. So to get x by itself, we need to divide by this number, but our calculator is fine handling that. When I did this, that was not happening. But we're going to go 13 divided by the tangent of 43 degrees, and we're going to hit enter. And it'll send us to our next problem. Did I enter something wrong? 13 divided by tangent 43, 13, opposite over adjacent, x. I had a 13.9 and it's not on here, and I can't go diagonally. Well, what the heck? I wrote the angle down right. I've got 43. I crossed off my hypotenuse. I've got opposite over adjacent. 13 divided by the tangent of 43. I got 13.9. I didn't get 12.6 or 12.7. I try one more time. 13 divided by tangent of 43 degrees. 13.9 again. Oh! That means I have to, there's a 13.9. Sorry, I was just looking left, right, up, or down. It's going to send you, I was like, what the heck is going on with my calculator? Because I'm doing it right. So you have to head diagonally across over to the next problem, which has a 57 degree. It's fine. We're good. So this is x is about 13.9, and it's going to send you on the left diagonal. This is due Thursday, but you won't get a whole lot of time to work on it tomorrow. A little bit, but not a whole lot. So just kind of know that you have that to work on. You could maybe do some at home.